Right, well, welcome to week 10, Object-Oriented Programming, often abbreviated to OOP or OO Programming or just OO. So a whole exciting new way of thinking about programs. So in this particular video, I'm just going to talk about what OO programming is and why it came about and why it's a good thing to know about. So the whole motivation drive behind a lot of programming language development in the past has been how it is for our poor little weak human brain to manage the complexity and performance of computer programs. So initially when we had computers, right in the very start, they were programmed in machine language, which was just sequences of bits. Very soon we moved to something called assembly language, which gives you a textual representation of the same thing. Move from location A to location B. Then came what were called high-level languages in those days, which were the next step up. They were designed for scientific and commercial programming, C and Fortran, and they dealt with simple numeric data. So you had integers and you had floats, and that was about it really for the most part. COBOL, you had decimal data, that is to represent currency without approximation. Then came along languages like Pascal and Modular, which increased the importance of the idea of type. And particularly when we got into Simula 67, this is 1967, pretty old, we started to talk about how you modeled the real world in computer programs. And at that point, the idea of type became even stronger, and a new idea emerged, that is object-oriented programming. So all modern languages, C++, Java, C#, Ruby, and even Python, have the idea that the programmer can define his or her own types for data manipulation. And that's what we're going to do in this week of the course. So the idea of type is familiar with you. You've met all those types there, ints, floats, bools, etc. And you're familiar with the idea that every object of some type has its own internal data, which is different from one object to the next. So I can have one list, list1, which is equal to the numbers 10, 20, and I can have some other list, list2, which contains a list of strings, for example, that string and this string, whatever. So the objects have different data inside them, but they have the same method. So if I try and do a do of list1 to find out what it will do, and I do a do of list2 to find out what it will do, I get the same, exactly the same output in both cases because they're of the same type, so they have the same set of methods. And although it wasn't quite so obvious to you, all of the accesses you've done to data inside an object, such as list 1 of 3, or 2 because we don't have a 3, oops, list 1, 2, we don't even have a 2. How about list 1 of 1, then we get the number 20. You're actually calling a method to do that, and it's hidden from you by the front end of the Python interpreter, which translates it into this: get the item from the object. That's a function call or a method call with the value 1, and it returns 20. And this will make a little bit more sense later on. When you look at the Python library, you discover a heap more classes are available to you. So if we look in the library reference here and we skim down to somewhere vaguely interesting, like date time, for example, we find a type date time that is used to represent dates and times, so that you can subtract two dates and find how many minutes there are. You can compute with hours, minutes, seconds, days, etc. And there's a whole heap more. In this slide here, for example, there's a fraction type for dealing with rational numbers. There's a priority queue for handling items coming in which have to be serviced with some priority, sockets for internet programming, a web browser even, turtle graphics and so on. Lots and lots more. Do look through the library sometime. It's fun. There's so much stuff there. When you're programming, you quite often find that you're dealing with items that appear to be passed around in groups. So if you're dealing with color images, you're often passing a red, green and blue to represent a particular color. And so you're setting a pixel in the image to a particular red, green and blue, or you're getting a particular red, green and blue from a row and a column. And so there's a notion of a type here, that the red, green, blue together represent a color. when you're making moves on the noughts and crosses board. We passed around the row and the column, for example, and we got it back when you ask the player for a move, they return which row and column they want to play in. Again, you can think that this is a notion of a move or a square selector. Now you can do these with tuples, and we've seen some examples of that in earlier super quizzes and the labs, but that gets clumsy. And so what we're going to introduce in this part of the course is the next step forward, where you write your own classes to represent these. And here's a very trivial example that I'll just quickly demonstrate here and run it. When I run that, no surprise, it prints 1020. It consists of 2 bits of code. The first bit defines a new class. It's got some magic stuff in it. We'll explain that in due course. But once you've defined that, you can then manipulate or create points as single variables which contain an x and a y value, and you can print out their x and y. And this is a big step forward to writing clean, simple code. So that's all I wanted to do in this video. Thanks for watching. Next video, I'll show you how you go about writing such things.